Okay, today we're going to do a little bit about atoms in the periodic table and look in a little closer detail at protons, neutrons, and electrons, where you can find them, what it means, how to look at the periodic table, and tell me exactly how many of each of those kinds of things that an element has. So the point of this brief lesson today is to be able to, when we're done, tell me the charge of an atom or an element, tell me the mass of the element, the location of the electrons, neutrons, and protons that are in the atom. All of this starts with a guy named Dalton, who proposed that all matter is made up of tiny unique particles called atoms that can't be subdivided. Here's the thing. We know now that this is not true. So what it meant at the time was that there were atoms and there was nothing smaller than atoms. Well, 200 years later, we know that there are things smaller than atoms, and atoms are made of protons, neutrons, and electrons. And in fact, those particles are made of smaller particles, but he was on to something. Another part of his theory was that if you are in the same kind of element, then all of your atoms are exactly alike. So if I'm carbon and I have 12 million carbon atoms, then every single one of those atoms are all identical to each other. And then thirdly, we could have atoms from these different elements that join together and form molecules. So I could have carbon combined with hydrogen in some form or fashion to make a compound or a molecule that contained both of them. So basically, what's in an atom? Well, all atoms are composed of three basic particles: protons, which have a positive charge, neutrons that have no charge whatsoever, and electrons, which are negative. The important thing here is to know where these particles are. Protons and neutrons are in the nucleus. So inside the nucleus, we have positive charges and we have particles that have no charge. We're going to talk about that in a minute. Why is it important to have particles in there with no charge? Then electrons are negative and they exist outside of the nucleus. So let's look at a model here of an atom. What we've got here in this part right here is a close-up of the nucleus, which has those protons or neutrons, and you can see where they're numbered out. And so just for the sake of argument, let's count how many protons or purple particles we can see. 1, 2, 3, 4, 5, 6, 7. I can see 7 protons in this model. And just because we can, let's count how many neutrons we have. 1, 2, 3, 4, 5, 6. I also have 7 neutrons. You're going to find, as we do an example in a minute, that that is not always the case. But what we have right here in this model, inside the nucleus, are 7 protons and 7 neutrons. What would happen, do you suppose, if I took the neutrons out and I just left 7 protons? Well, what would happen is I would be left with 7 particles that all had the same charge, positive. And if you've ever played with magnets before, you know that like charges repel each other. So if I took those neutral, zero charged particles out, I'd be left with 7 positive charges repelling each other. And if they repel each other, that means my nucleus is not going to stay intact. So the purpose of a neutron, a neutral particle, is to separate those positive charges from each other, but allow them to exist still relatively close to each other in the nucleus. The more positive particles or protons you add, the more neutrons you need to add to keep them separated. If you look at the periodic table, the first row or two of elements has a pretty even amount of protons and neutrons, but as we go further down the periodic table, you find that it takes more and more neutrons. We can't have an even number of protons and neutrons. So inside the nucleus, we've got protons. The whole periodic table is arranged by proton number, meaning as we go across the periodic table and down, we're adding one proton each time we hop to a new box. The mass of a proton is considered to be 1 atomic mass unit, or 1 AMU. No two elements on our periodic table have the same proton number because the proton number is your identity, right? It's who you are. So helium, sitting in position 2 on the periodic table, has 2 protons. Oxygen at 8 has 8 protons. If you look at neon, it's element number 10. Neon would have 10 protons. If we also then look at neutrons, they don't have an electrical charge, but they do have a mass of 1 AMU, or atomic mass unit, just like protons. So let's do a quick example here. If I draw helium, and it's element number 2, his symbol is He, and I can write his name down here, and I put his atomic mass at 4, we know that those protons each have a mass of 1. So if I'm going to figure out the mass of helium, I know that 2 protons have a mass of 2 AMU. If I know that the overall mass is 4, how many neutrons does this have? I know I have to have 2 more atomic mass units. Well, helium has to have 2 neutrons in order to get to this mass of 4 on the periodic table. We'll do more with that in a minute. Then we have our electrons, which are outside of the nucleus. Electrons have negative charges. It's why they are attracted to the positive nucleus, right? Opposite electrical charges attract each other. They do have a mass. Electrons are matter, so they do have a mass. However, that mass, in comparison to protons and neutrons, is so small that we ignore it when we calculate the overall mass of the element. What is the mass of an electron? Well, get ready. The mass of an electron, which we're going to consider 0, is 9.10 times 10 to the minus 31 kilograms. That means that you have 31 zeros behind a decimal point before you ever get to the number 9. Infinitesimally small amount. If you're looking at the periodic table, we consider all of the elements on the periodic table as they are to be neutral. And if they're neutral, that means that protons and electrons are the same. So if helium has 2 protons, then it also has 2 electrons to come out with a net 0 charge. Not all elements are neutral, though. In reality, most elements exist in a form called an ion, which means they have an electrical charge. They've either gained electrons or lost electrons. So we need to play around with this whole, what are the protons, neutrons, electrons, and how do I know if it's not just big and obvious to me? You're going to have a worksheet that looks similar to this. And you can see I don't have all of the periodic table here, but I've got a zoomed in part of the periodic table. And what we want to do is practice looking at the periodic table and counting up protons, electrons, neutrons, and some of these other things that we've got. I do want to call your attention to this right up here. This is called nuclear notation, and it gives us some important things. One, it gives us the element. So we can, by that symbol, identify the element. It gives us the atomic number, and we can identify that that is the number of protons. It gives us the mass number. Mass number is going to help us tell how many neutrons are in there. And then finally, we see an oxidation number, And that tells us how many protons or neutrons, or protons or electrons that the atom has gained. So we're going to look at this symbol quite a bit as we work through some things. How do you approach this worksheet using a periodic table? Well, let's look at our first thing. Our first element here is magnesium. So if I find magnesium on my periodic table, I see he's right there. In fact, I'm just going to go ahead and circle him so that we've got him started. So if I want to start filling out this table, where do I start? Well, I found magnesium. How many protons does magnesium have? Well, magnesium has 12. Because remember in an earlier video, I told you the whole number is going to be the number of protons. How many electrons does it have? Well, as it appears on the periodic table, and as it appears here, as I've written it, there is no plus or minus charge, so that means that electrons are equal to 12. So there's no charge. 12 positive charges, right? 12 negative charges, that's 0 charge. How do I find out the number of neutrons? Well, we're going to come back to neutrons in a minute. Atomic number. Atomic number is equal to the number of protons. So that's 12, right? We're going to skip mass number for a minute. We're going to look at average atomic mass. Average atomic mass is that decimal number. Remember I told you that in a previous video. So we're going to say 24.305 is the average atomic mass. Average because there's usually more than one version, and it is the average of all of their masses. And then we can finish off with symbol, which is Mg, which you were given here. So really the element name could be magnesium right there. Fairly straightforward. But what we're left with is this column for neutrons and this column for mass number. So let's start with mass number. We filled in average atomic mass here at 24.305. Mass number is equal to protons plus neutrons. The number of neutrons is the mass number minus protons, because protons plus neutrons give you the mass number. Well, I can't have part of a proton. I can't have part of a neutron, which means mass number has to be a whole number. No decimal. No decimal here. Well, my periodic table only gives me 24.305. How am I supposed to know what the mass number is? Well, if you're not given something like this symbol up here, if all you're given is what I gave you there, then what you have to do is take the average atomic mass and round it. So for this example, 24.305 would just be 24. Now that's going to be a very specific version of magnesium, magnesium 24. We know if the average atomic mass is 24.305, there is a heavier version of magnesium that exists. Magnesium 25 has to exist, but not given any other information, you go to the average atomic mass and you round. So now that we've done that, we can figure out the neutrons because we can take our mass number of 24 and subtract 12 protons, and we would have 12 neutrons. Now, don't get excited. It doesn't always work out this nicely. Let's look at the second example, okay? We've got magnesium, but now we've got a 2+ charge. What the heck does that mean? Well, let's go through this. Protons, magnesium still has 12 protons. It still has an atomic number of 12. Its symbol is still Mg. Its average atomic mass is still 24.305. But mass number is still 24. But now we're dealing with an electrical charge. We're dealing with electrons. Can we figure out the neutrons? Yes. 24 minus 12 gives me 12, right? 24 is the mass minus 12 protons gives me 12 neutrons, right? Mass number minus protons. But what is this doing with electrons? Well, we've got an electrical charge here, and the electrical charge will be written for you. What that electrical charge means is that version of magnesium has 2 more positive charges than it does negative charges, right? So here's what we've got. So protons plus electrons, minus electrons gives you the charge, right? Well, in this case, we know that the charge of magnesium is +2. We know that the protons are 12. Just because it says +2, don't get confused and think that it has 2 more positive charges, so it has 14 protons. The protons are the identity. So if I had 14 protons, I'm a different element. But 12 minus what number gives me +2? Well, that's 10. So in this version of magnesium, we only have 10 electrons. 12 positive charges is 2 more than 10 negative charges to get you a +2. Last, let's look at this titanium here. Titanium. Let's do some erasing. And let's pick green. Titanium is right here on this section of the periodic table. So we can do the easy things first. Number of protons. That's that 22 atomic number. So a proton number and atomic number are the same thing. Symbol, Ti. Average atomic mass is down there at 47.87. Mass number. Remember, we don't have anything out here. We don't have anything that looks like this that tells us the specific one, so we get to round. 47.87 would round to 48. So now I can figure out the number of neutrons by taking 48, right? Number of neutrons equals the mass number, which is 48, minus proton number, which is 22. So that's going to give me 26 neutrons. How many electrons? Well, I don't have a symbol there. So we assume that everything is neutral, which would be electrons equal to protons. So now that we've gone through a little bit, you should be able to figure out protons, neutrons, electrons, atomic mass, mass number, average mass, and it's your turn to go practice. There's an assignment waiting for you in Google Classroom.